Okay, continuing our discussion on integrals. These are some of our basic rules of integration. So this is for brief calc, so we don't have to deal with sine, cosine, tangent, inverse trig, and such. I recommend that you stop the video now and fill in the answers to all these. You need to simply memorize these in order to do integration. So, assuming you stopped the video, we'll go ahead and do them together now. The integral of constant dx is kx plus another constant c. And you can always check it, or rule for integration by taking the derivative. The derivative of kx would be k, and the derivative of c would be 0. So the derivative of this has to equal what we started with. X to the n we increment the power by 1 and divide by the same constant. E to the x was its own derivative, and of course I have to put a plus a constant on each of these. So e to the x plus c is my answer here. Integral of b to the x is b to the x over the natural log of b. You'll recall the derivative of b to the x is natural log of b times b to the x, which would cancel that, getting us back to there. And just like students, I tend to forget my plus a c. So we do want to remember this. There's always a plus a c degree of freedom on our integration. 1 over x is natural log absolute value of x plus c. The next two are constructive rules. They allow us to kind of manipulate integrals a bit into some of these other forms. A constant times a function of x, we can take the constant out of the integral. So the constant can come outside the integral or back in, depending on our needs on a particular problem. And plus or minus can be rewritten so this means if your problem had plus, we can use the plus rule, f plus g. Or if it had minus, we can break down sums and differences as the sums and differences of the individual integrals. So this will allow us to do some problems that have combinations of things we already know. We can pull constants out of the way and break them into the pieces we know how to take the integrals of.